Hello dear learners, Assalamu alaikum. Hope you are well. Welcome to CPSCS online class and my channel Chemistry School. This is Shafikul Shafik with you. Dear learners, today we want to discuss about the atomic spectrum. Dear learners, the concept about the spectrum came from Mr. Niels Bohr model. Dear learners, we know that when the electron moves around the nucleus, then the electron doesn't emit or gain energy itself. But if we heated this, then the electron just absorb energy and reach to the higher energy level. And alternatively, when we stop heated, then the electron now come back to its own energy level from higher energy level by releasing or emitting energy. Dear learners, look at the whiteboard here. There is a figure. There is a simple figure of atomic model, atomic structure. Here, this is the center, I mean nucleus, and these are the different types of energy level. This is the first energy level, this is second energy level, this is third energy level. Dear learners, look at here. When the electron of first energy level just jump to the higher energy level in the third energy level, then this electron absorb energy. And if that electron now fall on the lower energy level, I mean the third energy level to first energy level, then this electron radiate energy. We know that when electron radiate energy, this energy reaches to the environment as the combination of color. So this is the combination of color. Combination of color, and we know that this combination of color is spectrum. The singular form of spectra. And by this, from an atom, we can easily create the spectrum. Dear learners, when the atom just create the spectrum, this is called the atomic spectrum. How the atomic spectrum will form, dear learners? Look at here. There is a figure. This is a glass tube, dear learners. This glass tube fill up with hydrogen gas. If we apply here the strong electricity, I mean the spark in hydrogen gas in this glass tube, then from the glass tube, the yellowish radiate ray will emit from the glass tube. And when we just passes these emitted rays from prism, then we can get some lines. We can get some spectrum with definite wavelength here. These are the spectrum like this from hydrogen. We can red, green, indigo, violet. Different types of spectrum we can get from here. Mainly four spectrum we can get from hydrogen atom. This is the atomic spectrum of hydrogen. And like this, according the atomic spectrum, there is two type of spectrum we have. One is emission or radiate spectrum. Radiate spectrum. This spectrum is bright, combination of bright lines, GRIT, bright lines. Okay, dear learners, bright lines. And how the emission spectrum, when the emission spectrum will form, when the electron just jump from higher energy level to lower energy level, then the electron radiate energy or emit energy, dear learners, emit energy, then the emission spectrum will form. The emission spectrum will create bright lines in the spectrum series. And number two is absorption spectrum, dear learners. When the electron just gain energy and jump to the higher energy level, then the electron absorb energy, and from this we can get the absorption energy, dear learners. This is absorption energy is in the dark line, black line, some black combination, some black lines. Okay, dear learners. And how can we find out the spectrum? Spectrum is just find out by its wavelength. Each and every spectrum line having a particular wavelength with particular color. And if we get the wavelength of the spectrum, then we can easily find out the color of the spectrum. Here there is a Rydberg equation to find out the wavelength. Wavelength. How can we find out wavelength? Find out the calculate the wavelength of any type of spectrum, dear learners. This is the formula. 1 by lambda is equal RS 1 by n1 square minus 1 by n2 square. Look at this here, dear learners. This is the wavelength. I mean, the lambda is the wavelength of the spectrum. Here RS is the Rydberg constant. The value of this Rydberg constant is 109678 per centimeter. Okay, and here N1 is the lower energy level. I mean, here look at this. This is the N1. I mean, N1 means the lower energy level, and N2 means the higher energy level. Look at this. This is the N2. N2 means the higher energy level. Also here, this is the N2. This is the N1. So here we can get the values of N2 is 3 and N1 is 1 here. If we put these values here, then we can easily find out the wavelength of the definite spectrum here when the electron just jump from higher energy level to lower energy, I mean jump from third energy level to first energy level. We can easily find out different types of spectrum, like when the electron jump from fourth energy level to 1, fourth to 2 energy level, fourth to 3 energy level, or 5 to 1, different types of spectrum we can get. And for your better understand, dear learners, some information is written here on the left side here. Look at this. This is the scale for the spectrum. Look at this, dear learners. This spectrum always indicates by lambda. We can easily find out the wavelength from the spectrum. Here lambda always expresses here in nanometer. When you just find out the lambda here, then you just convert the values to the nanometer, then compare the values here. Different types of values shows different types of color. Look at this, dear learners. This is the scale. Lowest spectrum wavelength, which wavelength is lowest here, cosmic ray, and accordingly the increasing way, gamma ray, X-ray, ultraviolet ray, visible ray, infrared ray, microwave, and radio wave. Okay, dear learners, if the wavelength of the color is less than 0.0005 nanometer, then it will be the cosmic ray. And when the wavelength of the spectrum is 0.0052 to 0.01 nanometer, then it will be the X-ray. Accordingly, this is the this is the gamma ray. Accordingly, X-ray. Accordingly, UV ultraviolet ray. Now visible ray. This is the important for you. Visible ray. There is some mathematical problem, some creative question will be set from this range here. Visible ray, which is visible for us, we can see this type of color. There is 7 color we can easily see from the wavelength here. Look at this. If you want to just remember this term VGR, here 7 colors are present there. V means the violet, I means the indigo, B means the blue, G means the green, Y means the yellow, O means the orange, and finally R means the red. The range of the values of the lambda is here 380 nanometer to 780 nanometer. If you get the values of wavelength in the range, within the range, then you can easily say that these are the visible color, visible spectrum. now here I just write down separately for individual color here, violet for 382 for 24 nanometer. If the wavelength will get in this range, then the spectrum will violet color, like indigo color, blue color, green color, yellow color, orange color, and finally red color. Then red color is 647 nanometer to 780 nanometer. Okay. So from 780 nanometer to 1 millimeter, then it will be the range of IR rays. And 1 millimeter to 1 meter, then it is the microwave. From 1 meter to 10 kilometer, when the wavelength we can get, then it will be the radio wave. So largest wave, largest spectrum, largest rays is radio wave, and lowest is the cosmic ray. This is the important information for you. These are the discussion regarding the atomic spectrum, dear learners. Just you can easily find out what type of spectrum will form here. That's all today, dear learners. Thank you for watching my videos. Keep watching, and if you like these videos, please comment, share, and subscribe my channel. That's all today. Allah Hafiz.